Welcome back, AutoCAD programming enthusiasts. Just as I promised in the first video, now I'm going to really explain how the architectural Windows program works. And let's go to the code. All right, here we are at the top of the file. And I'm going to go through all the code sequentially. I just put in some meaningful remarks up on top. And this right here, this loads my support functions if they're not already loaded. Here are some global constant variables. You can change the frame thickness or the frame height, the glass thickness, and you can choose the window frame layer that the frames go on. You can choose the window glass layer here and define a maximum wall thickness of 40 centimeters. Or inches. In any case, here's the main function here, c:\window. C:; means it's a command that's accessible on the AutoCAD command line. This here will toggle your snaps off because when a program is running, it might be drawing, and if it's drawing, a program never draws with snaps. It always indicates the exact point, and if snaps are on, that could screw up the point input. These two lines create the window frame layer and the window glass layer if they're not already created, like when you have a new DWG file that you just started. This will load a standard error routine which makes sure that if the user presses the escape button to exit out of the command, that is snaps are turned back on again if they're on, and other settings. Now, what clear user input does is it changes some system variables to make sure that the program will work in a predictable manner and consistent manner. And this here starts the main the main window commands dispatch loop, where it asks the user to choose upon one of four options: new window, adjust an existing window, delete an existing window, or exit. And depending on that, it executes a block of code. This is what happens when a new window is to be drawn. And also, it's the default if you hit enter or spacebar. And maybe I'll go through how this works a little bit later on, but in the end, what it does is it calls create new window from rect in wall, which we'll see later. If the user chooses the adjust option, it executes this code here, and what it does in the end is it runs this function here, adjust window, which creates a new window based on user input, which is using an existing window. If the user chooses delete, this code block is executed, and in the end, it basically runs this function here, delete window and window dictionary. And of course, if the user chooses the exit function, it runs this block of code, which just sets continue to nil, and continue is the variable that determines whether the while loop is repeated again right here. Okay, now this function, create new window from rect in wall, figures out which 3D solid wall entity the 2D polyline rectangle, the parameter PL rect here, is on, on the surface of, how thick the window is there. It calls the function draw window from rect with that information, and an assumed side of the 2D polyline that the 3D solid wall is on, and then test to see if the resulting window is inside the wall or not. If it isn't, this function then deletes that window and its window dictionary. Then it calls draw window from rect to draw a new window on the other side of the 2D polyline through the handedness parameter, which I'll talk about later on. And I'll cover that later. This is the meat of the code in here, which I will get into after I explain some important concepts that you need to understand in order to understand this function. Now this function right here, draw window from rect, it figures out the window geometry from the rectangle using the 2D polyline passed to it in rect. It uses this entity coordinate system, which I'll explain later, and its 2D entity coordinate system points using some matrix math function calls, and then passes that info to the draw window function, which you can see right here at the end, to do the actual window drawing and creation of its window dictionary. And then here is the draw window function that the draw window from rect function calls in the end. And this is the function that actually draws the window and creates this window dictionary given the required geometry. Its return value is the window dictionary's entity name. And the function parameters are, and here are the parameters, okay? The function parameters are the window origin point, and that's the origin point, which is the 0, 0, 0 point of the Windows coordinate system. X hat, Y hat, and Z hat right here. That's the X, Y, and Z unit vectors of the Windows coordinate system. X length and Y length right over here. That's the lengths of the window along its coordinate system's X and Y axes. Wall thickness is the thickness of the wall that the window is in. The wall entity is the handle of the 3D solid that the window is in. Handedness, that's the handedness of the Windows coordinate system. As it turns out, this isn't needed in this function. I just realized this. And besides, you can figure that out from the unit vector. And just in case any of you don't know, this slash here separates the function's parameters. That is the information that's passed to the function when it's called. And this slash here separates the parameters from the private variables. Okay, and the private variables are variables that are needed by this function here, and they're not global variables. In other words, when you exit this function, these variables, if they've already been defined outside this function, are not affected. And if they haven't been defined outside this function, they still remain undefined. They're private temporary variables. It's very important to do this because if you don't do this, they're going to overwrite each other in the outside the this function, and your program won't work, and things will start getting really crazy. So that's a very common error that people do. They start using public global variables as private variables inside their function. And for example, if you use a CTR function, CTR or int or something like that inside a function and outside the function, they're going to overwrite each other. And here you can see is doing some basic math to figure out the geometry here. And then it goes about creating the geometry through the box command and the subtract function, and another box command, and then it creates the uh, glass entity here through another box function. And then it actually goes up through, it actually defines 5 um, coordinate systems, user coordinate systems to draw the geometry. The fact that you're using user coordinate systems makes the mathematics much, much easier. I'll be talking about that later. And then this code here, it actually creates the new Windows window dictionary, and it puts in all the geometry and all the other information, including the entity names that have been made up. Where is it? Wall int handle and wall thickness. These are the wall entities handle and and the glass entities handle. And so all this information is put into the new window dictionary, and then it's returned as the return value of the function. Now this here, the get window dictionary gets the current DWG files window dictionary. What is a window dictionary? It's the dictionary that all the window dictionaries are put in. And I'm going to explain all about these dictionaries, which holds all the data which makes this program smart, in a future video. It's going to be soon. It's really exciting. It's really awesome. And so this here line, it calls the above function when this program file is first loaded in order to get the global, set the global window dictionary variable for use with this program that points to the window dictionary of the current drawing. Here is the function adjust window, which is called when the main program loop, when the user chooses that option in the main program loop. And I'll explain this some other time. Basically, it figures out which one of the window corner points is closest to the indicated point that the user gives. And then it goes and it changes that window point to the newly specified point. And that function actually calls this next one get window corner points. It takes from the window coordinate system and the x length and y length of the window. It figures out what the actual points of the window are, and it returns it. I'll get into that later on as well. This function seals up a rectangular hole for a window according to the geometry of the window stored in this window dictionary. This function does the opposite. It creates a rectangular hole for a window according to the geometry of the window stored in its window dictionary. This actually deletes the window, the entities, and its window dictionary from the window dictionary where they're all kept. And optionally, it seals the window's wall hole. Right here it says seal hole, seal window hole. Seal hole is a parameter. If it's nil, it's not done. If it's anything else, it is done. And then, here and in this right here, it actually deletes the the dictionary is removed from the window dictionary. Here's a function that determines if a given entity ent is part of a window. It goes through the window dictionaries in the window dictionary to see if ent is part of a window. If it is, it returns the window ID. If not, it returns nil. Hey, shut up. Okay, this here function, it sets the user coordinate system. It creates a user coordinate system, actually, to what the Windows coordinate system is. That Windows coordinate system is stored in the dictionary. And here you can see it's extracting it from the dictionary with the VLX LData get function. Oh, that I'm going to explain to you later on when I talk about dictionaries. Now, U3, what this is, that's a function I created just to call the UCS function. Instead of saying command UCS and blah blah blah, I just say U3. You'll see that function later on when I show you my support functions file. Now, is window and inside wall, that just takes a window entity and it figures out if it's actually inside a wall entity, which are both passed to it. And it does it through the intersect command, which is stock AutoCAD, in a very clever way. I'll talk about that later as well, of course. Now, these here are diagnostic functions for debugging: print window dictionary, number of window dictionaries, and delete all window dictionaries. You can take a look at them. You can see how to handle manipulate dictionaries in a more straightforward way. This is some legacy code that I might resurrect, but that is a quick um, explanation and guide to the code inside this Windows command. Let's see, have I covered everything here? Oh yeah, I should have talked about this first, but all right. As you've seen, this program works using 3D solids, vector math, and matrix math because of 4 user coordinate systems. Hold on. Because of user coordinate systems that we use to draw the windows, entity coordinate systems because of the use of rectangular 2D polylines to place windows. 6, AutoCAD's intersect command, which I just showed you, to detect overlapping 3D solids. And of course, AutoCAD dictionaries for persistent non-graphical data storage, which allows the program and the AutoCAD entities comprising the windows to act smart. And that's how the program works. I think that's it for right now. Actually, I got an appointment. That was my cell phone alarm going off. So this is the perfect time to stop. I hope you enjoyed the video. Maybe it's about time I start asking you guys to click on the like button, I guess, and the notify button. And you should also become a subscriber or whatever they call it to the channel. Okay, I would very much appreciate that. And please go on to the next video, which I'm about to make right now. But by the time you see this, it'll probably be already online. So have a wonderful night, and I'll be talking to you again real soon. Right now, if you want, if you just click the next video. Have a great night.